Hello everyone, my name is Hadi, and in this session I'm gonna talk about scientific notation. What is the scientific notation? Scientific notation is used to show and calculate very large or very small number. So we use scientific notation when we have very large number or we have very small number and we want to enter it to calculator, computer, multiple, divide, or this type of thing. So working with very large number or very small number in the original notation is going to be very hard. Just imagine that we want to calculate how much light travel in 1 year. The speed of light is 300,000 kilometers per second. In 1 second, light travel 300,000 kilometers. So it travel very fast. And in 1 year, if we want to calculate how much light travel in 1 year, we should, 1 year is 365 days, and each day is 24 hours. Each hour is 60 minutes and each minute is 60 seconds. So if we multiply 365, if we multiply 365 days, multiply by 24 hours, multiply by 60 minutes, multiply by 60 seconds, this is going to be number of seconds in 1 year. And if we multiply the total of this one by 300,000, which is the speed of light in 1 second, the number that we will reach, it's going to be almost 9,061 and 1, 2, 3, 4 and 12 zeros in front of it. If we want to read this number, is thousands, million, billion, trillion, quadrillion, so is 9,461 quadrillion meter, which is, as you see, is very big number, 9461 and 12 zeros in front of it. Or if we want to calculate the speed of, if we want to calculate the mass of one proton, the mass of one proton is actually, if you studied chemistry, we have atoms. In each atoms we have protons and the electrons that's rotating around the protons. So the mass of each proton is 0.261673 kilograms. So can you see how small is this number? Actually, it's not possible to read it, to give a name for this number. Decimal, 26 0 after decimal, and 1,673 kilograms. So this is very small number. So I showed you two examples. One example which about a very big number, a speed of actually distance that light travel in 1 year, and the other one is very small number, the weight of the mass of one proton. For writing this one or for calculating this type of number, we use scientific notation. In scientific notation, we always keep a digit between 0 and 1. It means 1 digit before decimal. If I show it with x, 1 digit before decimal, and then keep all the non-zero digit after the decimal, as many as non-zero digits that we have after the decimal. The important thing is all of them should be non-zero digits. Multiply by 10 to the power of positive or negative number. So the general format is x, decimal, non-zero digits after the decimal, multiplied by 10 to the power of positive or negative number. Okay? So as an example, if I want to convert this number, the mass of proton, to the scientific notation, it's gonna be this number, mass of proton. It's gonna be, these are the non-zero digits that I have, 1,000, 1, 6, 7, and 3. These are the non-zero digits that I have. I keep only one of them before the decimal, and then decimal keep all the non-zero digits after decimal, which gonna be 6, 673. So I keep this one decimal 673, then multiply by 10 to the power of. Then we should calculate how we change the position of the decimal in the original number compared with the final number, scientific notation. So the decimal was here at the originally. We move the decimal after this one. How many positions we moved? We have 26 zeros and one plus one for this one. Actually it was here. We moved it. Let me use another color. I moved this decimal from here to here. Okay, which is 26 zeros plus 1 is 27. So the number that I need to write here is going to be 27. Now I should figure out the sign of this exponent, which should be positive or negative. Compare the final number with the original number. As you see, the final number is bigger than the original number. The decimal was here, we moved it to the right. So in this one I should put the exponent in a way that if I calculate this one, I return back to the original one. So if I put positive here, it means I should move this decimal to the right. If I put positive 27, I should move it to the right, which is not going to go back to the original. So I should put negative here, negative exponent. Then what's going to happen is 1.673 multiplied by 10 to the power of negative 27. Then what can happen? If I calculate this one, because this one is negative, I should move this decimal 27 position to the left, which I return to the original number. We want to calculate 721 and 6 zeros. This is the original number, is 721 million. If I separate 3 by 3, is 721 million. It's not very big number, but just for practice, we want to convert it to the scientific notation. For converting to the scientific notation, keep one digit and then put a decimal, keep all the non-zero digits, 2 and 1, multiply by 10 to the power of. So the original number, it doesn't have decimal. So it means decimal is at the end, and I move the decimal to this position in the scientific notation. How many positions? 1, 2, 3, 4, 5, 6, 7, 8. I moved 8 positions to the left and make the number smaller in this case. So I should put this exponent should be 8, and because this number is smaller than the top one, this exponent should be positive. So in this case, if I multiply this one, 7.21 multiplied by 10 to the power of 8, it means I should move the decimal 8 position to the right, then I go back to the original one. Another example. Let's say I want to convert 0.1234567 2031. I want to convert this decimal number to the scientific notation. Now, keep one digit before decimal, 2, then put the decimal, keep all the non-zero digit, is 031. Can you see, even though we have this 0, but because we have 31 after this 0, we keep all of these 3 digits. Then multiply by 10 to the power of. I moved the decimal from here to here. Yeah, I move it after 2. How many digits? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So 10 to the power of 9. Now we should look at the sign of this exponent. Because I moved the decimal to the right. In this case, when I'm multiplying this one, I should move it to the left. Or I should move the decimal to the left to make the original, to return to the original. If I leave it at positive, I should move it to the right, which is not going to go back to the original number. So I should put a negative sign here. So is 2.031 or 2 and 31 thousandths multiplied by 10 to the power of negative 9. This is the exponent, the scientific notation format of this standard format or decimal format of the number. Okay, I hope you enjoy from this session. See you in the next session. Bye for now.